So today we're going to be looking at integration by parts, and we're going to be working out 4 different problems today. And towards the end, I will actually show you a situation in which we have to use integration by parts twice. So let's begin here. So our first problem here, we have the integral of x times sine x. So we have this and this. It's always good to get in the habit of writing the integration by parts equation, for every time you work a new problem. That way it'll be easier for you to remember. Now, when it comes to solving problems of integration by parts, it's always good to look at the problem and always ask yourself, okay, what would be easier to get the derivative of, and what would be easier to get the integral of? So in this case, it will actually be easier to just go ahead and get the derivative of x. So we just go ahead and set u equal to x, and the derivative of x will be dx. Next, we'll set our integral equal to sine. So now we're looking for the antiderivative of sine x, which will be negative cosine x. So now that we have that here, so now that we have the information there, all we really have to do now is just plug this into our integration by parts formula. So it will look like something like this. So we're first going to start off with plugging in our u and our v, right? So we know what that is because it's here already. So because we have a negative here, I'm going to go ahead and put the negative out first, and then put the x cosine x dx. I like to separate things around to make them look aesthetically pleasing and easier to work with, because sometimes you can miss like the signs if you don't put them correctly. So always pull out stuff like that, and then negative the integral of v du is what we have to plug in next, which we know that will be negative cosine x dx. We have 2 negatives here. Let's go ahead and make them positive. Now we know that the antiderivative of cosine is just sine x. And that's our answer for that one. Okay, now the second problem here. So we're going to do the same thing again. Let's get into the habit of writing the integration by parts formula. U dv equals u times v minus the integral of v du. And once again, ask yourself, what would be easier to get the derivative of, and what would be easier to get the integral of? So let's go ahead and set our u equal to x. The derivative of x would just be 1, so dx. The entire derivative of e to the negative x, well, that's going to be v equals negative e to the negative x. And then at this point, we can just go ahead and start plugging things in. Now, you might be asking yourself, okay, well, how is this, like, what happened here? So let's kind of split this problem up for a bit here. Let's focus just on the integral of e to negative x. Okay, dx, sure. So we can set this part here, the negative x, equal to, we're going to be using u substitution here. So u will equal negative x, du will be dx. Now there's not a negative here. So we can just go ahead and multiply that by a negative, and that now makes it into a positive. So now we're looking like, so this here is now looking like this here, and the negative, we can just pull it out of the integral. And we got now e to the u, because now this became u because we're using a little u substitution here, right? And so once you get the integral, now the integral of e, we know that it's just going to be e to the u plus the constant. Now we're not done here yet, because we still have to replace our u here with our original, and we know that that's going to be our negative x plus our constant. So that right here is how I got this. So now we just have to just start plugging things into the integration by parts formula. So remember our u and our v, okay? And we know that our u and our v, that's going to be negative x times e to the negative x minus, now here is when we start to plug in the v du part. Looking back here now, we can start to see that our v is going to be negative e to the negative x dx. We get two negatives here. We just make that positive. And we know that the integral of this, we already know what this is going to be because we already worked it out. And it's not actually, so it is a plus, right? But really what's going to happen is that you're going to have this. So then that's going to bring it back to a negative. And so then that would be our answer for that problem. So it's always good to review your derivatives and also your antiderivatives. Because honestly, as long as you know those and you memorize those, this will be easy to work with and easy to solve. Now our last problem. So on this one, well, actually it's not our last problem, sorry. So on this one, it's just the same thing. We're doing integration by parts again. And so once again, let's get into the habit of writing our integration by parts formula, which is u dv equals to u times v minus the integral of v du. And by looking at this, I can go ahead and tell you it will be much easier to get the derivative of natural log. So we'll set that equal to u. We know that the derivative of that would just be 1 over x. And the antiderivative would just be 1/3 over 1/3 times x to the third. Oh, jumping around today. So now that we have that here, it's all just a matter of plugging in things into the equation. Now, I'm not going to write this whole thing again. So I'm just going to set it equal to I. So now we plug in our uv. So now we plug in our uv, which that would be 1/3 x cubed times natural log x minus rv du, which that's going to be 1/3 x cubed times 1 over x dx. Now, by looking at this here, you will notice that we actually have a constant. So we can go ahead and pull that out. And that would leave us now with x cubed times 1 over x. Now, the way I would think about this is that we have, let me do this in a different color. You have 3 x's, right? And you only have 1 x on the bottom. One of the x in the denominator will cancel out the 1 in the denominator, leaving you with just x cubed right? But then you also got this 1 here. So really it's just this. It's x cubed times 1. And there you go. And so now that got simplified, we write this again. 1 over 3 times x cubed times the natural log of x minus 1/3 x cubed dx. And so now all we got to do is just integrate this part right here. So I'm going to work this off to the little side here. So what we really got to do now is just add 1 to x cubed in the denominator and also in the denominator, which then will be obviously 2 plus 1 is 3, and so we can just pull out the 1/3, and then our answer is going to start looking like this: 1/3 times x cubed times the natural log of x minus, well, we're quite at the answer, but not quite just yet. So we got 1/3 times what we just got from our integral, from integrating x squared. So then this will give us now the final answer of 1/3 times x cubed times natural log. These two are multiplying, so that'd be 1 over 9 times x cubed plus our constant of integration. And so this right here will be our answer. And then last but not least, this is gonna be an interesting one. I'm kind of already dreading it. So once again, out of habit, let's write our integration by parts formula. So it'll be u dv times equals to u times v minus the integral of v du. Okay. Well, it'll be, in this case, it'll be easier to just go ahead and set our u equal to x squared. The derivative of this would be du equals 2x dx. And then the entire integral would just be sine x. And then that would actually equal to a negative cosine x. So now that we have this information here, we can start already to work with this and start plugging in to our integration by part formula. So I'm going to set this equal to I, so I'm not having to rewrite this thing. So this will be I equals, and now I'm going to be plugging in our u and our v, which then that will be negative x squared times our cosine of x minus our v du, which that would be a negative cosine x times 2x dx. Now 2 is a constant. We can just go ahead and pull that out we can pull that out onto the other side of the integral here. Let me show what I mean by that. And then we also have these two negatives. This will actually be positive. X cosine x dx. Now what happened here? So what I did here is that for starters, we have two negatives here and here. They're positives, and the 2 are brought out outside the integral, and then we're left with an x. And for aesthetics, I decided to move it to the front here, or right here. So now it looks easier to work with. So now we solve this part. So let's focus now on right here. Now notice that we have to use integration by parts again to solve the rest of it now. So we're going to do, let's do it like this. So now we're going to set u equal to it'll be easier to get the derivative of x. So u will be equal to x, and then du dx, and it'll be easier to get the entire integral of cosine, which then would be sine x. And once again, we have to use our integration by parts formula here. So then, rewriting what we have up there. Oh, that was really bad. Let me fix that there. So this would be negative x squared times cosine x plus 2. So I'm going to put this in brackets there. So now here, we're going to have to start putting our uv minus v du. And I'm actually just going to go ahead and go back up here, and we'll finish it off around here. Oh, snap. So then, we're just going to have to rewrite x cubed cosine x plus 2 and plug in our u's and our v's, which then it will be x sine x minus the integral of sine x dx. Which then that would give us this part here would just stay the way it is as of right now. So it'd be x sine x, and then we get the entire derivative of sine, which we know will be negative cosine x and we can just, since there's two negatives here, we can just go ahead and add them together and make them into a positive. Sorry, multiply them together. And then that will be sine x plus cosine x plus our constant of integration. And that is your final answer. So one thing to keep in mind is that whenever you're working with these types of problems, it's always good to, well, one, know your derivatives and also your integrals of, your sines and cosines and literally everything else. And also, it's always a good idea to get in the habit of having to write the integration by parts formula for every new problem you're working, so that way it'll be easier to remember. And also be cautious about your signs, your negative, your positive signs, because those can sometimes make a difference as to what the answer can result. And so, yeah, thank you guys for watching, like and subscribe, and stay tuned for new videos.